Hong Kong is famous for its fantastic urban development. Beyond lie the attractive hills and valleys of a dynamic natural landscape. Sadly, most visitors to Hong Kong do not go beyond this urban area. What you're about to see is a natural physical setting of Hong Kong. The Special Administrative Region of Hong Kong is a compact area that is characterized by a varied and attractive landscape, possessing a fascinating geology, a wide range of landforms, and many different ecological communities. Hong Kong is situated on the south coast of China, just inside the Tropic of Cancer, and experiences a monsoonal climate which is almost subtropical. Hong Kong consists of a small peninsula in southern China, which together make up administrative areas well known as Kowloon and the New Territories, and many islands, of which Hong Kong and Lantau are the best known, but there are also about 230 smaller islands. Hong Kong has a total area of 2,900 square kilometers, of which almost 60% is sea. Thus, Hong Kong has a long and scenic coastline of about 800 kilometers. The landscape of Hong Kong is rugged, with several high peaks including Tai Mo Shan, Lantau Peak, Sunset Peak and Lion Rock. Steep hillsides and a cliffed coastline are characteristic of the natural terrain, with the only extensive areas of flatland occurring in the northern and northwestern parts of the New Territories. Level ground is otherwise restricted to small areas on valley floors and along the narrow coastal fringes. Remarkably, the urban area occupies only 15% of the region, an area that includes nearly 40 square kilometers of reclaimed land that fringes the coasts. Almost 75% of the Hong Kong region is classified as countryside, about 40% or over 41,000 hectares of which is preserved as country parks designated under the Country Parks Ordinance of 1976. Today, only 7% or 80 square kilometers is agricultural land. There is a lot of fascinating geology in Hong Kong, even in the urban areas. One good place to start your study is the Sai Kung Rock Garden, put together by the Agricultural and Fisheries Department. Let's go there and take your S112 Unit 5 text with you. This rocky outcrop of volcanic material is a nice example of undivided coarse ash crystal tuft of the Tai Mo Shan Formation. You will study these formations during the mapping exercise in our Earth Science Lab back at the Open University of Hong Kong. There is an almost monument-like look about this outcrop. Even rock can be beautiful. Now we shall have a look at what the rock garden has to offer.
I'm sure you remember this book on Earth Science, Unit 5 and 6. Into the Earth, the earthquakes, the seismology and magnetism. This is a blue book, a key book in your Earth Science for S112. And just inside on page 8, we have your laboratory story about sedimentary rocks, igneous rocks and close-up shots of these rocks. Yes, that's the laboratory story, but right here in Sai Kung, not far from the Ho Man Tin campus, we have some fantastic rock samples of Hong Kong, rocks from Hong Kong, about the rock bases to the Earth Science course. And today we're going to have a close look at these fantastic specimens. If there is a rock of Hong Kong, it's this granite here. And this is our theme rock in some ways. And I'm touching a very nice specimen here in the Sai Kung Rock Garden. And I want us to have a close look at it. Over here, the bright, shiny, unweathered granite. And let's go down here to this great sample of Hong Kong's weathered granite. And one of the themes of this earth science course that we're doing is change in rocks over time. And weathering is one of our big topics. And I'm sure you would like to have a close look at this surface here. It takes a long time to change from that to this. And the process of weathering, physical and chemical weathering, and biologically assisted weathering is one of our big ideas.
We hope that you can visit this rock garden as well. Bring a clipboard and a camera and make your own illustrated booklet about the rocks of Hong Kong. You need not come to this Sai Kung garden alone. It's a pleasant and educational place for your family too. Some of the oldest rocks in Hong Kong were formed by ancient volcanic eruptions. Today, these rocks underlie about 48% of Hong Kong, and they form the landscape of most of our country park. What is the story revealed by these rocks? Evidence of one spectacular volcanic event can be seen near High Island East Dam.
Using very accurate dating techniques, we've determined that the rocks behind me here are 141 million years old. So what we know is that 141 million years ago in this area, there was a very large volcanic eruption. We think that the volcanic centre was over to the west of us in the Sai Kung area, that this material was very large volumes of hot ash that came from the volcano over Sai Kung and settled in a large depression here, a caldera, a volcanic crater. It accumulated probably as one very large event and then cooled slowly over many thousands of years. As it cooled, these vertical columns formed. The phenomenon is known as columnar jointing, and the joints form vertical to the cooling surfaces, which is the upper surface and the lower surface. As the material slowly cooled, it became more plastic and probably settled, and so over in this direction we can see some of the effects of that cooling and displacement, forming these beautiful curved structures. So this is probably a feature that formed during the cooling process when the material was plastic and it slowly settled into another depression or was squeezed out slightly to the side. After these rocks had been deposited and had cooled, the initial appearance was a dark grey to black rock like this. But the processes don't stop there. Once the rocks have hardened, they're then subjected to the agents of the atmosphere, to the sun, to the wind and the rain, and they begin to deteriorate by a process known as weathering. What happens? The rock changes colour. The first visible sign is for a change of colour to something like this, which is white and bleached, or to something like this, which is iron stained. Combined with this, there is a loss of strength, so the rock becomes weaker and breaks up into the fragments that we can see around me here. You will notice the variation in colours, mostly reds and browns and oranges. What happens? The iron from the original rock is mobilised by weathering, and the iron is drawn out to the edges of the rock like this, giving a hard coloured coating. And then if you look at the inside of the rock, you can see it is actually a lighter colour. So the iron has migrated to the outside, to the joint faces, and the rock starts losing its colour until in extreme examples like this it becomes very bleached and very white. This loss of colour and loss of strength leads to collapse of the rock, and so we see this sort of debris that's around me here, that as it weathers, loses its strength, it falls off, and so this cliff behind me is actually moving back very slowly because of weathering and collapse.